All right, everybody, let's take a look at problem A for problem number 2. So we've got this cord, we're at the top of a swing, and so we're going to have the tension pointing down, and we're going to have the weight pointing down here. So for A, this is just for part A. Now, why do we say this? Remember, the force from a rope goes out of the object along the rope. That's why we have the tension pointing down. And then we have the weight pointing down. So I've begun with the free body diagram. Now let me just go back and label each number here with the appropriate variable. So this is the radius, this is the mass, and once again, please be careful. Meters per second means that this is the speed or the velocity, v. We'll say speed. We could talk about direction, but I don't want to get into what the direction of this 3 meters per second is in a beginning physics class. So the tension in the cord at the top of the swing. Well, to really solve this, we're going to need to write down the forces equation using Newton's second law. So we know that F net is m times, you know what, I want to write the given stuff in purple. So this is given. I would tell you that F net is m times a centripetal. And now the idea is F net is the sum of all the forces acting. So we have the weight and the tension, and the effect of these is that the mass accelerates in a circle. And I want to be clear that at the top of the swing, okay, downwards is the positive direction. So that fact, I don't tell you that. You have to know that on the exam. And then here we're going to have m times g for weight plus the tension is m times a centripetal. And we'll keep going here. 0.5 times 10 meters per second squared plus our unknown tension is going to be 0.5 kilograms. Now for the centripetal acceleration, let's be careful. We need to plug in our given formula here. A centripetal is v squared divided by r. So I'll actually plug that in here. For v, we put in 3. And for r, we put in 0.5. So this is going to be 3 squared divided by 0.5. And it turns out these cancel. It's just a coincidence. And that this is 0.5 and that's 0.5. So we get 5 plus t is going to be 9 newtons. And so we get a tension of 4 newtons in the cord. That's how we resolve part A.